We've been discussing Java classes and the various inheritance hierarchies that they exist in. Today we're going to talk about what exactly happens when we take those objects as various classes and we pass them into methods as parameters and we return them as return values, and how inheritance works with that. The big rule that the compiler enforces in this situation is essentially that in any circumstance where an object of some class BBB is expected, then it's always acceptable to substitute an object of a subclass, but never of a superclass. Now, the reason for that is pretty straightforward, right? A subclass of BBB inherits all of BBB's methods, but you can't make that same guarantee about the methods in a superclass, right? The method of a superclass belongs to an object that is not necessarily a BBB, whereas a subclass of BBB definitely is a BBB. Take a look at this code segment, which sort of illustrates this idea. We can see we declare three variables: an abstract shape, a circle, and a wheel. And then we're creating a bunch of objects. We're instantiating a bunch of circles and a wheel and pointing those variables at them. So when we point an abstract shape variable at a circle object, that's fine, because a circle is, in some sense, an abstract shape through that hierarchy. If we point a circle variable at a circle object, well, that works too. That makes sense. But if we point a wheel variable at a circle object, well, that doesn't necessarily work, because a circle is not necessarily a wheel. It works the other way. A wheel is a circle, as we can see in the next example, but the inheritance hierarchy is a one-way relationship. For the rest of this lecture, we're going to apply these ideas to method parameters and return values. So we already know that objects can be passed to and returned from methods. And if we're being more precise, we would say that references to objects or pointers to objects can be passed to and returned from methods. Now, obviously, an object has to exist before you pass it to a method, but it's sort of easy to forget that any changes you make to the object in that method, they live on after the method stops running. They persist. Remember, it lives on the heap. On the other hand, if you return an object from a method, generally speaking, you'll probably have created that object inside the method. And that also continues to exist after the method stops running, as long as there's something pointing to it. As a first example, let's write a method that takes a rectangle as an input parameter and returns a circle. Okay, the circle has the same area and same position as the rectangle. This method isn't going to make any changes to the rectangle, and it has to instantiate the circle. So we can see its return type is circle, and its parameter type is it takes a single parameter, one rect, which we call rectangle. It works reasonably. We get the area of the rectangle and we store that as a double variable called area. Then we back calculate what the radius of the circle should be. We create a new circle with the same position and that new radius, and then we return a reference to that new circle object. Very sensible, not too confusing. But now let's modify that method so that it can take any shape as an input parameter, like a circle or a rectangle or a wheel, and generate a circle with the same position and same area. Now, this is pretty straightforward as well. And that's largely because we can guarantee that any shape understands the area method. That's a great advantage of using the shape interface. So again, our behavior here looks actually substantially the same. Only difference is, instead of taking a rectangle specifically, we take a shape, we just get that shape's area, store it, back calculate the radius, and make our new circle, which we then return. Again, nothing too complicated. We'll now tackle a slightly more complex task, where we're going to write a method that returns an arbitrary rather than a specific shape. So this method actually takes two input parameters. The first one is a shape itself, and the second tells us what kind of shape we want to return. For instance, circle, rectangle, or wheel. We can see the way this works. We start by declaring a shape variable, which will ultimately point at the output shape. We also declare a bunch of variables: area, radius, width, and height. Not sure which ones we're going to need right now. We'll definitely need area, but the others we may or may not need depending on what type of shape we're trying to produce. We get the input shape's x position and y position, and then we get the input shape's area, which we store in our double area. Then we embark on a series of conditional logical statements where we're saying what we want to do if we've been told to output a circle, if we've been told to output a rectangle, or if we've been told anything else, which we assume means a wheel. You can see if it's a circle or a wheel, just as before, we're back calculating our radius and creating our new, whether it's a circle or wheel object. and pointing out shape at it. If it's a rectangle, well, then we're back calculating what the width and height should be. And in this case, we're actually assuming that for our rect, the width and height will be the same. So I guess actually our rect object will truly be a square. Then we're creating a new rect object and pointing our out shape variable at it. Finally, at the end, we return out shape, having instantiated it to the right type. Now let's have a look to see how this would work if we were actually using it. So in some class called test shapes, we'll have a main method, and we'll also have the method that we just looked at on the last slide, make one shape from another. So here's how we might call it. We might create a rect, and we might create 3 shape variables, shape 1, shape 2, shape 3. We make our new rect, giving it its x position, y position, and its length and width. And then we might call make one shape of another using circle, rectangle, and wheel. And then we could print the areas of each of our output objects, which are now pointed to by shape 1, shape 2, shape 3. We can see those references are returned from make one shape another and are ultimately set to shape 1, shape 2, shape 3. Here I've got this set up in Eclipse. I've got test shapes in my class, my main method, the method we just looked at, make one shape from another. And if I click run, we can see in the end, perfect, I've got 4 shapes printing out their areas, 24, 24, 23.9999, 24. Little floating point imprecision, but the methods worked as we expected. 2 key checks for your understanding that you can do before hanging up your hat at the end of this lecture. First, what's the rule for passing a parameter of one class to a method that expects a parameter of another class? In particular, we're thinking about class hierarchy and how this works in terms of that. Second, if we assume that some class BB is a subclass of AA, and we also assume that method M expects a parameter of type BB, which of these 2 method calls is correct and which one is going to throw an error once you try to compile your code? If you can answer those 2 things, you're probably in good shape.